Hello everyone, welcome back to my next tutorial. So this video is a continuation of the previous one. If you have not watched that earlier video, I suggest please go and watch it first so you can follow along all the tutorial. Okay, so in last video, if you remember, we covered zone 1, right? Zone 2, here we discussed this zone in last video, right, where we discussed the zone 1 component. If you remember, that's included EMI filter, right, then bridge rectifier and DC bus capacitor. And also we discussed zone 2, where we talked about PFC module, MOSFET and and IGBT switching, if you remember, right, then high frequency transformer. So all these zone 1 and zone we have covered our journey from EV power conversion from grid to battery, right. So today we will talk about zone 3. Let me jump to the slide. Yeah, this is our last zone. So we will look at all the component in zone 3 one by one. Here we discuss, okay, we had already obtained DC current in our zone 1 and zone 2. So question is, why do we still need all these component that is lying in zone 3, right? Why it's needed? Okay. So this session is regarding this. We will try to answer this. And finally, we will review the entire process using 3D animation. Okay, all these EV power conversion that we have discussed, I will show you with help of a 3D animation. So, so you will relate it. Okay, you will really enjoy this video. So it will help you to relate the concepts that and visualize the thing what we have discussed so far. Okay, so let's get started. Our last zone. So last zone is safe delivery and power storage in the battery. That is saying DC to battery. Okay. Now we are enter zone 3, the final stage. Here our job is very simple. Take the processed power and deliver control DC to the our EV battery, and again we have 3 stages in zone 3 that we will going to be discuss, right. You can see in the PPT here, this is 3 component. After zone 2, this 3 component is lying in between zone 3. Okay, we will talk one by one. As you can in the PPT, in zone 3 we have first component is secondary rectifier, then output filter, and finally EV battery. Okay, so moving ahead, here did not we already converted AC to DC in zone 1 and zone 2, right? So after the bridge rectifier, do you think the DC output is perfectly smooth, or it does still contain a ripple? If you think it still has a ripple, what do you think remove that ripple? Right, because ultimately we need a smooth DC for our EV battery. We have to be remove all impurities and unwanted ripples, right. If you know the answer, please comment your answer. Okay, so this is the couple of questions that should to be come in our mind after discussed all these point in our last videos. So first is like, which stage do you think is the most important for the safety charging the EV battery, and why? Think about this. If the bridge rectifier converted AC to DC already, why do we need all the stage after it? Why of it's important? Why these are necessary? Right? These are the some question that we have to be that we should to know the answer of this, right. Is the DC after a rectifier is really smooth, that is a compatible to our battery? It is enough smooth for the DC to charge our battery? If you know your answer, please comment. Okay, so think about it and write your answer in the comment section. Okay, so remember what happened in zone 2. We converted the DC into high frequency switched waveform, so it could pass through the transformer. If you can recall our last session, and after the transformer, we therefore need a rectify that secondary side waveform back into the DC, right. So that job is done by the secondary rectifier, that is here in zone 3, right. Then our output filter, after rectification, we still want a clean and stable output, so we use the output filter. It's help to reduce the remaining ripples and a smooth final DC output. Okay, and finally our EV battery. If you can see here in the PPT, so finally the energy reaches the EV battery as controlled DC power. So this is the destination of our entire conversion journey. Okay. So now moving ahead, you can see in the PPT, this is showing you the complete power conversion architecture that so far we have discussed. We have started our journey from the AC grid. Then we have divided our whole entire process in 3 zones, if you can remember. In zone 1 we discuss about the EMI filter, bridge rectifier, DC bus capacitor. In zone 2 we discuss about PFC, MOSFET IGBT switching, its working, right? High frequency transformer, okay. And in third zone, the component we discuss secondary rectifier, output filter, and the EV battery finally. So if you have not watched my earlier video, please go and watch it. It was a very wonderful journey. You will learn all these things, the application of the components, how their role and responsibility, how they are using here, okay, how they are their role to converting the AC grid to the smooth DC to our battery, okay. So now let me play video for you. Let's understand what we have discussed so far through a video, okay. You will be able to relate it, I am sure. Let's jump to the video then.
Electricity from the grid travels as an AC sine wave, but it often carries unwanted electrical noise. An EMI filter targets and removes this noise, leaving only clean, reliable power. Electricity from the grid travels as an AC sine wave, but it often carries unwanted electrical noise. An EMI filter targets and removes this noise, leaving only clean, reliable power. Electricity from the grid travels as an AC sine wave, A bridge rectifier converts this into DC. It uses 4 diodes labeled D1, D2, D3, and D4, rectification. During the negative half cycle, the opposite diodes D3 and 4 conduct. Notice that the current is redirected in the same output direction. This process creates continuous DC power. During the negative half cycle, the opposite diodes D3 and 4 conduct. Notice that the current is redirected in the same output direction. This process creates continuous DC power. During the positive half cycle, diodes D1 and D2 conduct. The current flows through the forward bias diodes to the output. This produces the first DC pulse. During the negative half cycle, the opposite diodes D3 and 4 conduct. Notice that the current is redirected in the same output direction. This process creates continuous DC power. Watch the complete AC waveform enter the bridge rectifier. The positive and negative half cycles are both converted. They emerge as a series of positive pulses. This output is called pulsating DC. The pulsating DC enters the capacitor. It charges up at each peak. Then it discharges to fill the gaps. This creates a much smoother DC output. Perfect. Following the DC link stage, the power factor correction circuit actively controls the electrical current. This PFC circuit corrects the waveform. This makes the power distribution much more efficient. Following the DC link stage, the power factor correction circuit actively controls the electrical current. This PFC circuit corrects the waveform. This makes the power distribution much more efficient. When voltage and current are misaligned, power is wasted. PFC solves this by adjusting the current waveform. This leads to better power quality and improved efficiency. Is that simple? Rippled DC current flows from the secondary rectifier. It enters an LC filter stage. An inductor and capacitor work together to smooth the output.
Okay, all. So I try to show you all the journey from AC grid to the our battery through a video. Okay, so you can relate it very simply. So what look like one simple action is plugging in a EV is actually a careful control power conversion journey, right? Now let's find Let's finalize by reducing the entire architecture into 3 questions, what we have discussed till now. So, first question is, where does the energy started, if you remember? From the AC grid, right? What zone does one do? Is converted AC to DC, right? Next question, what happened in the middle? In the second zone we discussed, right, power processing, where we have discussed about the PFC, switching and high frequency transformers, right? We have covered all those components in zone 2. Next question, where does the energy end up? As controlled DC power at a EV battery, right? So remember this simple chain. Let me go back. Okay, yeah, this slide is also okay. So you can see in zone 1 we discuss AC to DC. Zone 2 we discuss power processing, and finally the last zone, the DC, control DC, that is going to the battery. If you understand these 3 zones, you already understand the basic architecture of the EV power conversion. Alright, let me give you the entire story in 20 seconds, what we have learned so far. So grid give us the AC. In zone 1 we filter it, rectify it and create a DC bus. In zone 2 we process that power using PFC, high frequency switching, right? We discussed the MOSFET, the IGBT switching and the transformer. In zone 3 we discussed the rectifier and filtered that power again. And finally the battery received the controlled DC power. Please comment your answer, how you feel learning this video, how you experience from our journey from AC grid to battery. Okay. Now, but now there is one question we have not answered yet, right? So, moving to our question answer slide. So, question that we did not discuss yet, how exactly do 4 diode inside a bridge rectifier take an AC sine wave and first in one direction and then other, and make the current flow in the same direction at the output, right? That's what we will see in next session. We will detail discuss about the rectification, the diode, okay, bridge rectifier, its application, okay. We will take the positive half cycle, follow the current through the 4 diodes and then take the negative half cycle and see what changes. So when you see those 2 current path, the bridge rectifier became very easy to understand, trust me. Okay, so in our coming videos we will discuss all these things. Once you see those 2 rectifier path, the bridge rectifier became very easy to understand. So today we have followed the complete journey of the electrical power from AC grid all the way to EV battery. We started with AC, then bridge rectifier converted AC to DC, right? All those journey we have covered. But here is some more question. If the bridge rectifier is already converted AC into DC, why can't we simply send that direct current to the EV battery? Okay, please comment your answer if you know the answer. Okay, why do we need all these stages in between after the zone 1? Okay, so after DC link capacitor, why we need lot of component like PFC, MOSFET, IGBT switching, then high frequency transformer that we discussed in zone 2. Why we need the secondary rectifier, and finally the LC filter that we discussed in zone 3. What is each stage actually doing here? Think about it and write your answer in the comment section. After the bridge rectifier, do you think the DC output is perfectly smooth, or does it still contain a ripple? Okay, so these are the couple of questions that should come to our mind after study all these things, right? If the bridge rectification converted AC to DC, why we need all these stage after it? If the DC after rectification really smooth for our battery? Please comment your answer. Until then, take care. Okay, and please subscribe my channel so this content can reach those who really needed it. Thank you for reading with me. Okay, and thank you for your support, and take care. We will meet again next session, so we will catch you later. Thank you.